Hello, ladies and gentlemen. Happy Wednesday. Today we are just going to do a graphing review. We're going to cover the four bases that we've covered so far, and then we're going to hammer it home with an assignment where you get to practice all four, and then tomorrow I'll have another quiz available specifically for cubic and for square root. But let's just jump into it. So the first thing we talked about was a linear function. A linear function. We said the graph, or I'm sorry, the equation was y equals ax plus k. And I'm going to be very specific with my descriptions to make sure everyone's on the same page. So, what did each of these things mean? The a, remember this is mx plus b, so the a is the slope, but what we were calling it was either a vertical stretch or a vertical compression. And what this looked like was a vertical stretch made the graph look like that, really steep, and a vertical compression made it look like that, really shallow. The K was a vertical shift, either up or down, or we could also just say that was the y-intercept. That was the extent of linear functions. That's as complicated as they get. So let's say for this graph, I don't know, let me make something up. Y equals x minus 3. Then what this minus 3 is telling me is my y-intercept. So I know it's crossing this axis right there, no matter what. Now, if I don't have anything here, if I don't have a stretch or a compression, then I know my slope is rise over run 1 over 1, but to avoid getting too complicated, because I don't know if you guys ever did that, if we do our t-table, 1, 2, 3, 4, my y-intercept is going to go in the middle. So it's negative 3, 0. That is my, 0, negative 3. That is my y-intercept. So, where we get the numbers up and down from this, these two and these two, is going up, we go 0 minus 1 and 0 minus 2. Then we do 0 plus 1 and 0 plus 2. Then, to find these numbers, we're going to plug in our x values into our original equation. So if we plugged in a negative 2 here, that would be y equals negative 2 minus 3. If you combine a negative 2 and a negative 3, you end up with a negative 5. If I plug in my negative 1 there, I get negative 1 minus 3. Negative 1 combined with a negative 3 gives me a negative 4. If I plug in a 1 there, y equals 1 minus 3. That gives me negative 2. And if I plug in a 2, y equals 2 minus 3. That's going to give me a negative 1. So here are my 5 points. I need to graph them. I need to give myself some more space on each side. So starting with the top point, negative 2 means left 2, and negative 5 means down 5. 1, 2, 3, 4, 5. Left 1, down 4. Left 1, down 4. I already graphed that one. Right 1, down 2. Right 1, down 2. Right 2, down 1. Right 2, down 1. Then when I trace this, I end up with a line. Okay? That's how you graph a linear. Now I'm going to do one that has a vertical shift, and we'll call it quits for linear. So let's say my equation was y equals 1/2 x plus 1. So, using my table, What is my y-intercept? Well, my y-intercept is going to be where it crosses the x-axis. That's 1 right there, or where it crosses the y-axis, and then that's going to be 0. So I know my first point is going to be 0, 1. That is my y-intercept. Now where do I go from here? 0 minus 1, 0 minus 2, 0 plus 1, 0 plus 2. So now I plug in my numbers. So I'm going to have to do it down here. Yeah, I'll do it over here. So if I plug in my negative 2, I have y equals 1 half times negative 2 plus 1. 1 half times negative 2 gives me negative 2 over 2 plus 1. Negative 2 over 2 is just negative 1 plus 1, and that gives me 0. So that's negative 2, 0. Negative 1, what happens when I plug that in there? I see y equals 1 half times negative 1 plus 1. 1 half times negative 1 is still negative 1 half plus 1. 1 minus 1 half gives me 1 half. So for negative 1, I get 1 half. If I plug in a positive 1, 1 half times 1 is 1 half. 1 half plus 1 gives me 1 and a half. If I plug in a 2, y equals 1 half times 2 plus 1. 1 half times 2 gives me 1 plus 1, y equals 2. So there are my 5 points. Let me make some markings so I have some room. First point, left 2, then I don't go anywhere. Second point, I go left 1 and then up 1 half. So left 1 up a little bit. The third point is 0, 1. I already graphed that. Fourth point is right 1, up 1, and then a half. The last point is over 2, up 2. There is my resulting line. And if you'll notice, this looks more like this because it was vertically compressed, because a compression means that your a value is a fraction less than 1. So that's why that was compressed. That's the extent of linear equations. Now let's talk about quadratics. Quadratic functions. So quadratic functions, our equation was y equals a times the quantity of x minus h plus k. Now, we've got a couple moving pieces here. We have a, h, and k. So a is going to be either a vertical stretch, if it's a bigger number than 1, or it's going to be a vertical compression. Don't forget the squared there, like I did. If you vertically stretch a parabola, it's going to look like really skinny. And if you vertically compress one, it's going to look really fat, because you're either squishing it down or stretching it out. Okay? So h and k. So remember, we switch the sign of our h and we keep the sign of our k when we write these numbers down. H tells us our horizontal shifts, whether we're going left or right, and our k gives us our vertical shifts, just like it does inside the linear equations. H and k together, which I'm going to call this point, is our starting point on the t-table. And not only is it the starting point on the t-table, I think I just forgot what I was about to say. Maybe it'll come back. Anyway, so if we go ahead and try one, I'll do 2 just like I did for linear. Let's say we had y equals, I don't know, x minus 2 squared plus 1. So if we had this graph, then we would need to work out an x, y, t table. 1, 2, 3, 4. So to get my middle point, I need to find my vertex. H and k are what I'm looking for. So h is in the parentheses, k is outside. So h would be negative 2, and k would be positive 1. But I switched the sign of h, so it's positive 2, positive 1. Now from here with a parabola, I'm allowed to go down 2, so 2 minus 1, 2 minus 2, 2 plus 1, 2 plus 2, and that gives me my numbers here. Now I have to plug each one of them into the equation to get my numbers. So for 0, I'd have y equals 0 minus 2 squared plus 1. 0 minus 2 is negative 2 squared plus 1. Negative 2 times negative 2 gives me positive 4 plus 1. That gives me 5. For positive 1, I would have y equals 1 minus 2 squared plus 1. 1 minus 2 gives me negative 1. Negative 1 squared, negative 1 times negative 1 gives me 1, and 1 plus 1 is 2. So, if I plug a 3 in there, y equals 3 minus 2 squared plus 1. 3 minus 2 is 1. 1 squared is 1, plus 1 gives me 2. Finally, I have a 4. Y equals 4 minus 2 squared plus 1. 4 minus 2 is positive 2. Positive 2 squared is 4, plus 1 gives me 5. So, that's where I'm getting these 4 points. Let's graph them. Okay, so 0, 5. So I don't go anywhere left or right, and then I go up 5. I go over 1 to the right, and then up 2. 1 to the right, up 2. I go over to the right 2, and then up 1. Over 2, up 1. Over to the right 3, up 2. Over to the right 3, up 2. Over to the right 4, up 5. Over to the right 4, up 5. My resulting graph looks like a pretty normal parabola. Hooray! Now what happens when we start getting into some janky a value territory? What if I had y equals, let's do 2 times the quantity of x plus 3 squared. What now? Well, nothing too scary. I just got to do my t-table again. What's my vertex? So if I compare this to my h and my k, what's my h? 3. And what's my k? I don't have one. So if I don't have a number, that means it doesn't exist, which means the number is 0. So I know my k is 0. And I switch the sign on my h, so instead of positive 3, it's minus 3. So my vertex is negative 3, 0. Now for parabolas, I can just go down 1, down 2, up 1, up 2. It's a little backwards with negatives, but it's fine. Now I have to plug in each of these numbers. I'm going to write pretty small so I can fit all this in. So negative 5. Y equals 2 times the quantity of negative 5 plus 3 squared. Negative 5 plus 3 is negative 2 squared. Negative 2 squared is 4, and 2 times 4 is 8. Negative 4. Y equals 2 times the quantity of negative 4 plus 3 squared. Negative 4 plus 3 is negative 1 squared. Negative 1 squared is 1, and 2 times 1 gives me 2. Oh, running out of room, oh no! Negative 2. Y equals 2 times the quantity of negative 2 plus 3 squared. Negative 2 plus 3 gives me positive 1 squared. 2 times 1 squared gives me just plain old 2. Last but not least, I think I can fit it, guys. y equals 2 times the quantity of negative 1 plus 3 squared. Negative 1 plus 3 gives me positive 2 squared. That gives me 2 times 4, and that gives me 8. So I have my 4 points. Time to graph. So I have left 5, down 8. So 1, 2, 3, 4, 5, and then, oh, I'm sorry, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Somewhere way up here. It's fine. Next, I have left 4, up 2. 1, 2, 3, 4, up 2. Next, I have left 3, 0. So left 3, 0. Then I have left 2, up 2. And left 1, up 8. What does my resulting shape look like? Well, this looks a whole lot like that, my vertical stretch, right? And that's because this was vertically stretched because of this 2 value, right? It's this 2 value. Great. So let's talk about cubics. Cubic functions, what do they look like? I'm going to be giving them to you in the same form, vertex form, that we had for quadratics, except you will have a 3 instead of a 2. Hooray. So what do we have here? Well, the A is the same as quadratics, which means it's a, I'm gonna abbreviate it, a vertical stretch or a vertical compression. A vertical stretch is going to look like this, really skinny, and a vertical compression should look more like this, pretty fat. So we still have our H and we still have our K, and the H and the K represent your vertex. It's also called a point of inflection, by the way. Not that you need to know that, but your vertex is still your opposite of H, K, and you're still switch and keeping. And that's really it. There's no there's little difference between a cubic and a quadratic when you're graphing it. So let's take a look at one. Let's take a basic one. Y equals x plus 3 cubed. I'm going to regret that. Plus 1. X, Y, T table. 1, 2, 3, 4. What is my vertex? Opposite of H. Keep the sign of K. So opposite of 3 is negative 3, positive 1. Negative 3, positive 1. Negative 3, positive 1. That's going to be my first point. So, going down 1, down 2, up 1, no, oops, up 1, up 2. All right, starting with negative 5. So, if I plug in my negative 5 to this equation, what do I get? Y equals negative 5 plus 3 cubed plus 1. Negative 5 plus 3 is negative 2 cubed plus 1. Negative 2 cubed is negative 8 plus 1, and that's going to give me negative 7. For the second one, if I plug in a negative 4, y equals the quantity of negative 4 plus 3 cubed plus 1. So, negative 4 plus 3 is negative 1. Negative 1 cubed is negative 1 plus 1 gives me 0. For negative 2, y equals the quantity of negative 2 plus 3 cubed plus 1. When I combine these, I get positive 1 cubed plus 1. Positive 1 cubed is still 1, plus 1 is 2. Then for the last one, I have negative 1. Y equals the quantity of negative 1 plus 3 cubed plus 1. Negative 1 plus 3 gives me 2. 2 cubed gives me 8 plus 1 gives me 9. So I have a full table. So let's graph these numbers. Left 5, down 7. 1, 2, 3, 4, 5, down, way down here somewhere. Left 4, stay put. Okay? 1, 2, 3, 4, stay put. Left 3, go up 1. Left 3, go up 1. Left 2, up 2. Left 2, up 2. Left 1, up 9, way up here somewhere. So when I trace this, hooray. My shape isn't that great, but it's really supposed to look more like this. A smooth curve. Mine's a little blocky and diagonal, but you get the point. So, the cubics are probably the ones that take the longest, in my opinion, just because the numbers are bigger. But this is correct. Okay? Let's do one more. This one including one of those awful stretches and shifts. Or, I'm sorry, stretches and compressions. One, two, three, four, five, six, seven, 8. I'm going to make it really big because I'm going to do a really big number. Let's do y equals 2x cubed minus 2. XYT table. 1, 2, 3, 4. What is my vertex going to be? It's the opposite of h. Do I have parentheses? No. So do I have an h? No. So what does that mean? It's 0. You keep the sign of k. My k is negative 2, so you keep negative 2. I move down 1, down 2, then I add 1, and I add 2. So, what do I do from here? I plug in my numbers one at a time, and it's going to take a while. I'll do it over here. If I plug in a negative 2 into this problem, I get 2 times the quantity of negative 2 cubed minus 2. That gives me 2 times, what's negative 2 cubed? Negative 8 minus 2. 2 times negative 8 is negative 16 minus 2. That gives me negative 18. Ooh. How the heck am I going to graph that? I don't know. Second one, we plug in a negative 1. Y equals 2 times the quantity of negative 1 cubed minus 2. Negative 1 times negative 1 times negative 1 gives me negative 1. 2 times negative 1 is negative 2 minus 2. That gives me negative 4. And I'm already out of room, so I'm going to have to do the other two over here. If I plug in a positive 1, I get y equals 2 times the quantity of 1 cubed minus 2. 1 cubed is 1, so I get 2 times the quantity of 1 minus 2. That gives me 2 minus 2, and that gives me 0. If I plug in a 2 here, I wind up with y equals 2 times the quantity of 2 cubed minus 2. This is a tongue twister. So that's 2 times, what's 2 cubed? 8 minus 2. 2 times 8 is 16 minus 2 gives me 14. Okay, that's a big ol' honkin' number, but let's graph it. Left 2 down 18. That's going to be somewhere way below the graph. I don't know. Let's just guess it's right there. Left 1 down 4. Left 1 down 4. Stay put down 2. Over 1, don't go anywhere. Over 2 up 14. Over 2, it's somewhere way up here. And when I try to do this justice and trace it, you'll notice that it's really long, just like we said a vertical stretched one would be, really long and skinny. And that's because of this 2 right here, which is a vertical stretch. Okay? That's cubics. Let's move on to square roots. So square root functions are the jankiest of the bunch. Our equation is y equals a square root of x minus h plus k. Remember that I said this square root symbol can confuse us, but we're just treating it like parentheses. So guess what? The a is literally still a vertical stretch or a vertical compression. Now, if it's a vertical stretch, our shape's going to look like this, really tall. And if it's a vertical compression, it's going to look like this, really stout. All right? So these had some special rules, and I told you there are certain numbers you want to end up with. You want 1, 4, 9, 16, or 25. Well, really, you could add 0 in there. You want 0, 1, 4, 9, 16, and 25 under the radical. That's our goal here. If you can get one of those numbers under the square root symbol, then the problem is just as easy as any of the other ones. The trick is figuring out those numbers, and I know some of you guys were kind of struggling with that, which is really why I decided to take today to review. So let's look at it. Let's say we had y equals the square root of x plus 1 plus 2. Make my t-table. I told you guys that these are unique because we can't have negative numbers. So usually in our t-table, we would go down 1, down 2. We can't go down for these because if we go down, we end up making a number that's going to be impossible. It's going to be imaginary. So instead of going down 2, we're going to start with the vertex. And then we're going to work our way up from there, which is maybe a little important note. These are unique. So what's my vertex? Opposite of h, keep k. What's my h? Positive 1, so I switch that to negative 1. What's my k? 2. Wow, that is the world's worst negative 1. There we go. So, now I gotta be creative. Okay, this is the part that nobody likes. I have the square root of x plus 1, right? I need to make sure that whatever the number ends up being in here, it's one of these in my list. So what's the closest one I have above negative 1? 0. How could I make x plus 1 equals 0? Well, I'd put in a negative 1 plus 1. If I plug in a negative 1 plus 1, that would give me a 0. Oh wait, I already have that. So what's the next one? I could find a 1. How would I make the square root of x plus 1 equal to 1? Well, I'd substitute in a 0, because the square root of 0 plus 1 gives me the square root of 1. Well, that works for me, because I wanted the square root of 1. So that's one of the options. Now, how could I get a 4? How could I get a 4? If I have the square root of x plus 1, how would I find a 4? Well, what plus 1 gives me 4? That would be the square root of 3 plus 1. So 3 is my number. Now, how could I get 9? What plus 1 gives me 9? Well, 8 plus 1 gives me 9. So I'd plug in an 8. We're going to have more practice with these if you're confused. So now that I know my numbers for x's, I just have to finish and plug all three of them into my equation. So I had y equals the square root of x plus 1 plus 2. Let's plug in my first value, 0. Square root of 0 plus 1 plus 2. Okay, what's the square root of 0 plus 1? The square root of 1 plus 2. What's the square root of 1? 1 plus 2, that gives me 3. Next one, if I plug in a 3, y equals the square root of 3 plus 1 plus 2. What's the square root of 3 plus 1? That's the square root of 4 plus 2. What's the square root of 4? 2 plus 2 gives me 4. Last but not least, 8. If I do y equals 8 plus 1 plus 2, that gives me the square root of 9 plus 2. What's the square root of 9? 3 plus 2 gives me 5. So, looks like I have my values. So, let's graph them. My first point is left 1, up 2. Left 1, up 2. My second point is stay put, up 3. Stay put, up 3. Third point, go right 3 and then up 4. Right 3, up 4. Last point is go over 8. Oh, wow. I need to go pretty far. Go over 8, go up 5. So, when I trace this, I end up with that dorky little shape. Hooray. Let's do one more that includes a vertical a vertical stretch or compression, and then we will call it quits for the review. And these take a lot of room, so I need to get a new piece of paper. Let's say we had y equals 3 times the square root of x plus 3, just for fun. Negative 3. Heck yeah, let's throw a negative in there. I forgot to do negatives today. Oh well. I hate making you guys wait for that. It's awkward. T-table for square roots. I'm starting with my vertex. So what is my h and my k? What's my h in the parentheses? 3. I switch the sign. It's negative 3. Do I have a k? Nope, so it's 0. So now I've got to move the square root of x plus 3 and try to get one of those numbers. I'm looking for a 1, a 4, a 9, or a 16. I already have a 0, so I'm probably not going to do 0. Let's try for 1. What plus 1, or I'm sorry, what plus 3 gives me 1? Well, an easy way to do that is to say what plus 3 equals 1, and then solve. Subtract 3 from both sides. 1 minus 3 gives me negative 2. That works for me. So it looks like if x is negative 2, I get 1. So let's throw a negative 2 in there. Now I need to find, I found 1, let's try to find 4. How would I make x plus 3 equal to 4? Well, I'm sure we could do that in our heads. It's probably 1. So if x is 1, then it looks like if x is 1, then 1 plus 3 gives me 4. So that works. Last one, how am I going to get 9? The square root of x plus 3. What plus 3 gives me 9? I think we could do that in our heads as well. 6 plus 3 equals 9. So let's do 6. Cool. So I have my x values. Now I got to plug those suckers into the original equation. So negative 3 times the square root of x plus 3. For the first one, negative 2. Negative 3 times the square root of negative 2 plus 3. Negative 3. What's negative 2 plus 3? It's positive 1. What's the square root of positive 1? 1. So negative 3 times 1, which is just negative 3. All right. Next one, we have 1. So if I plug in a 1, negative 3 times the square root of 1 plus 3. That gives me negative 3 times the square root of what's 1 plus 3? 4. Negative 3 times, what's the square root of 4? 2. What's negative 3 times 2? Negative 6. Last but not least, if I plug in a 6 here, y equals negative 3 times the square root of 6 plus 3. 6 plus 3 is 9. The square root of 9 is 3. Negative 3 times 3 gives me negative 9. So, I've got some beefy points here. Let's graph them. Left 3, don't go anywhere. Left 3, don't go anywhere. Left 2, down 3. Left 2, down 3. Right 1, down 6. Right 1, down 6. Write 6 down 9. Write 6 down way down here. If I follow this trail, that's the shape I get. Now, why does this look so different from this one? Why are they facing different directions? Because of Mr. Negative right there. Why is it so tall? Because A is a vertical stretch, which makes these look taller. So that is the extent of square root functions. In the description of this video, I have a link to a quiz. It is a practice quiz that has questions from all 4 types that we've done today. Instead of doing questions that I handwrite for you, I would like you to log into the quiz website and take that. It's not a quiz grade, it's going to be for a homework grade. In the questions, I'll have some that are very similar to the ones that you will see on your quiz tomorrow. Tomorrow, I'm going to have some questions on cubic functions, and I'm going to have some questions on square root functions. It'll probably be the same length and same type of questions that you had yesterday. It'll be yesterday by the time I record, or by the time we talk next. So, good luck to you. Please study these. If there's anything you don't understand, I'm free to text and free to help you with any of it. But after that, I'm praying for you guys. Have a good day.